In the above example, at 2 nautical miles on a 2.7 degree glide slope, the aircraft gets a 1 dot fly up indication on a 5 dot scale. How many feet is the aircraft below the glide slope? Right? So here, you're given the glide slope as 2.7 degrees. The range from touchdown is 2 nautical miles. And the aircraft, the indication is, the ILS indication is 1 dot fly up indication. So what indication is that? It's a glide slope indication, right? 1 dot fly up indication, and that is on a 5 dot scale. Remember, if nothing is mentioned, it is still a 5 dot scale. If it is 4 dot, they will tell you it is a 4 dot. Even if nothing is mentioned, it's always a 5 dot scale, right? Yes. You're asked to find out how many feet is the aircraft below the glide slope. It is very clear that the aircraft is not on glide slope, because if it is on glide slope, it won't show you this 1 dot fly up indication. Where is the aircraft? Is it below or above the glide slope?
It's below only.
It's below that.
Because it's saying fly up.
Fly up, yes. So let's draw that very quickly to understand how it looks. We're not bothered about the localizer here because it is not told. This is a 5 dot system, right? And the localizer, the indication is 1 dot fly up. This is the first dot here, 1 dot fly up indication, right? So what is the full scale deflection on a ILS glide slope?
It's 0.7 degrees.
0.7 degrees. 1 dot fly ups. Therefore, 1 dot deflection corresponds to 0.7 divided by 5, and that 5 is because it is a 5 dot system. If it is 4 dot system, we have to divide by 4. This is a 1 dot value. So let's draw the diagram. This is the runway here. Center line, X on the center line. This is your glide slope, which is 2.7 degrees. This is a common type of question that they ask for exam from ILS. The questions which we did before is more like the 1 in 60 kind of questions. Like this is a typical ILS question. So you are actually below the glide slope. That is why it is asking you to fly up. By 1 dot is 0.75 degrees. So you can see here. How much is this? That difference is 0.75. That is why they are saying you're below by 0.75 by 5, and therefore you have to fly up by so much. You're asked to find out what is the, how many feet is the aircraft below the glide slope. So now, what is the range of the aircraft? That is 2 nautical miles.
2 nautical miles.
This is the height of the aircraft. The aircraft is supposed to be here. How many feet below this height is the aircraft? Is the question. So basically you have to find out this particular distance. What is the, how many feet below the required height are you? Is the question. Now you can do this in 2 different ways. Let's look at the first method here. Now they are not distinctly 2 different methods, but one is a bit more longer, other is a bit more shorter method. You see, what is the general way of finding this? How can you find this residue at this small height?
So we can consider the present glide slope. So that is 2.7 minus 0.14.
That's right. Okay.
And then we can find the actual height of the aircraft and the height which it should have with 2.7 degrees. We can minus and
subtract those two, right? So we put some alphabets here to make it clear. This is alphabet A, O, A, and B. So basically, you're telling me you can find out OA, and then you can find OB, and you can subtract. Let's find that. So what is OA here? Height on glide slope, right? So what is this angle? This is basically 2.7 minus 0.5. So you see, your current glide slope is 2.56. So you multiply that with 100, and then you multiply that with the range, which is 2.
512.
512 feet. So this height is 512 feet. Now, what is the total height?
540.
What would this height be? That is on a 2.7 degree glide slope over 2 nautical miles. So how much is that? So the glide slope is 2.7. The actual glide slope you're supposed to be into 100 into 2. That is going to be 540 feet. Therefore, what is this AB? AB is the
28
here, which is 28. This is 540 minus 512, 28 feet
below the
slope. Method 2 is we don't have to distinctly find these two, but that is a much more easier method. What is this angle? The small angle difference is 0.77 divided by 5 is 0.14, right? Find, so you can see 0.14, just find out what this height would be for 0.14 over this distance. That is easier. So you can see the distance, height AB is equal to, this angle corresponding to AB is 0.7. That's why I told you don't find this answer 0.14. You can keep this fraction like that itself. Just keep it like that. Into 100 into 2. So how
yes,
much is that?
correct. 28 only. 28. Short.
It's a shortcut. Exactly. But it's a very logical shortcut, because if you actually find out, if you apply variables here, subtract it, and if you make an equation, you will get the same thing. So you get something which you can prove as well. Because in these two equations, if you take this 100 into 2, 100 into 2 is common. So what differs is only the difference between these two.